break open the rock and see what's inside. The problem with hammers is that it's very, very hard to have a robot use a hammer safely. It's difficult to do. People have tried and they get mostly broken robots instead of broken rocks.
Honeybee had designed more traditional-looking drills for other missions that had been canceled or delayed. And they were working on a large robot to crawl through New York pipes in search of leaks. Making something small, light, and able to work with very little energy would be a challenge.
Time has come to get inside the rock, to get the crucial information that's there.
Honeybee geared up to build the rat and test it to NASA's rigorous specifications. Early designs used a single rotating head. The resulting hole was not deep enough. Another design, 2 heads. A better hole, but lots of dust. And that was a worry to JPL and Steve Squire's science team. On Mars, dust could coat the camera lenses or sit on the solar panels and cut power. They tried a skirt, a piece of fabric girdling the rat.
I don't like the skirt because I feel that it is causing the dust that we're trying to get rid of to fall back in the hole. In the end, that's really what it's about.
Now, see, we don't know what the skirt does at these different angles. We don't know what happens without the skirt at these different angles. This whole thing has been sufficiently counterintuitive to me from the get-go that I'd rather see tests than guess what's going to happen.
Yeah, I hear that. I hear what you're saying.
Steve Squires said he thought the skirt should go, but that engineering should also follow the classic scientific process. Experiment, data, results, and then conclusions.
I was just questioning the testing it with this continual testing with the skirt, that's all. I just didn't quite understand why that should be so extensive. We'll do it. End of discussion, okay?
Okay.
104.449.
Skirt tests were jammed into an already tight schedule.
If we're grinding at an angle, then a lot of this dust that builds up as a crater along the rim of the ground area could build up inside the skirt if you're grinding, say, sideways, and it could all just fill in the bottom of the skirt. When you pull the rat away from the rock to put an instrument on, where's that dust going to go? It could fall to the ground and plume up and potentially cause more problems than solving.
So we're ready to begin grinding, and here we go.
In order to get accurate results, they used dust almost as fine as that on Mars. A vacuum chamber created Martian pressures. JPL supervisors made a point of being there.
Well, next test is going to be without a skirt, so we see where that goes. And then we're going to have to make some decisions.
Tests continued at Honeybee, but Steve was needed elsewhere.
All right, you're in.
We've tested the rat at 6 to 8 millibars, which is the Martian pressure, which is only about 1% of that of the Earth. And we find that it doesn't billow like it does on the Earth. It said it flies out almost in a straight line, the dust, which is good because it just goes away from everything. And so once we were able to establish that and show the Jet Propulsion Lab that the dust plumes were benign, we went through a formal change review, and the skirts were thankfully deleted.
Now on to actual flight hardware. This was the first time something built at Honeybee was close to getting launched. The young technicians were shown the rigorous procedures for how to keep it clean and safe. Every step was documented. Building engineering models and flight hardware went on round the clock, weekends included. But in early 2002, there were delays in getting motors. The Honeybees had to wait. Finally, FM1, flight model number 1, clean, tested, and carefully packed. was ready to be hand-carried out to JPL. Fast forward 4 years from Doodle to deployment on Mars. Now they were ready